Lesson 13, More Standard Deviation. Learning target. I can use standard deviation to say something about a situation. One big question we've asked ourselves this lesson is, what does standard deviation reveal? We know that standard deviation tells us how blank a data set is relative to the mean. It tells you how variable the data is relative to the mean. This type of information is important to have as it helps us understand the data that we're looking at. When looking for the best measure of variability, we have two choices. Standard deviation is calculated using the mean, so it makes sense to use it as a measure of variability when the mean is appropriate to use for the measure of the center. In cases where the median is a more appropriate measure of center, the interquartile range is still a better measure of variability than standard deviation. Let's take a look at our first example about basketball points. These two dot plots show the number of points that two players on a basketball team made during each of 15 games. Let's look at the dot plots to see what information we can determine. Let's first look at player 1. The data in the first plot has a mean of approximately 3 87/100 points and a standard deviation of about 2 23/100 points. The data in the second plot has a mean of approximately 7 73/100 points and a standard deviation of approximately 4 67/100 points. Player 2 has greater variability than player 1 because the data is more spread out. This shows the standard deviation for the second distribution is being greater than the standard deviation for the first. Smaller, larger. Let's look at a second example about race cars. Two professional race car drivers have the same average lap times after 50 laps. What does it mean to say the first driver's lap times have a greater standard deviation than the second driver's lap times? It means that even though the drivers had the same average lap time, the first driver showed greater variability in the lap times of the 50 laps. The first driver has lap times that were slower and faster and less clustered near the mean than the second driver's lap times. We'll go over one more example about student heights. We're going to look at data of student heights for two classes to answer the question, what differences would you expect to see in the dot plots that represent the distributions of data for each class? In Class A, students have an average height of 68 inches and a standard deviation of 5 inches. In Class B, the students had an average height of 67 inches and a standard deviation of 3 5/10 inches. Here is the dot plot for Class A. It does seem like the data is spread out and there's a pretty large range. We can summarize that for Class A, the data is more spread apart and centered slightly to the right when compared to the dot plot for Class B. Here's the dot plot for Class B. I notice that the data is definitely more clustered as the range is much smaller, and the data is more clustered around the mean of 67 inches, compared to how Class A's points are clustered around the mean of 68 inches. We can summarize that for Class B, the data is more tightly clustered around the mean.